also equal 424. Long is the repeating character replacement. For this question, we did this 5 months ago, but at that time, the time complexity for this is 26n, right? What we do is that we have left pointer, right pointer. We use some kind of like a 2-point template. Basically, we have the count equals new count 26, right? So for this question, it asks we can replace k at most k characters and find the longest consecutive same character string length. Right? So we have the counts first. Let's whichever have this one as cherry. The cherry, and we have inter left equals 0. Let's count. We just need to have the right pointer, left pointer, so the right equals to 0, left equals to 0, and we have the count maximal count, max count. That is the one in the slide window from the left to the right, the one with the most the longest counts, and also the longest at our result, right? Anything else? Let's get it in array of length out as well, right? So let's say right, that's right, that's plus, and let's say fonts array right plus minus a plus. So remember what we did before is that while left smaller than right, and we'll have a function called we'll say right minus left plus 1 minus get the max. So we want to get the max count. We'll have a function called get max from this count. Okay. So in this case, we'll have left plus. We'll have also counts. Array left minus this is capital, right? Capital A. We may have uppercase English character. So remember this kind of template is that if we have right minus left plus 1 minus get max, right? Get max smaller equal to k, right? Then we'll have longest equals max bottom max longest on the right minus left plus 1. In the end, we just return longest. Now, in the get max, private get max, private int get max, if we have int count. Yeah, so we need to iterate the 26 character in and get max. So we'll say this is a 26 multiplied by n time complexity. The follow-up question is that if this is not just in English uppercase character, maybe we assume, how about this question has more than 10,000 different characters, or 100,000 different characters, then this L, right, this length will be very large coefficients. So can we still do like a O(n) time complexity for this? We'll say actually we are able to. So for this question, we'll say this max. Actually, we don't need to calculate get max every time. This max will be max, and it's only possible these values will exceed max, right? And in this case, we're trying to get rid of this get max function, which is that max. But the thing is that if we use a while loop, right? Use a while loop, the thing is that we are calculating this max every time we move the left pointer. So there is another way that we expand the right pointer, right, and left, right, and every time we have the max from the right to left, and so on this step, if the right minus the left plus 1 minus max smaller than k, okay, smaller equal to k, right? Smaller equal to k. If this smaller equal to k, then we will not go to the while loop. That means we go to while loop only when we this condition, right, minus left plus 1 minus max is greater than k. This happens. So we need to when this happens, now the right and the left, the length, right? The length will be one more character than the longest so far. So what we are going to do is that we just have an if statement. We move the left point here to make sure the right and the left the window is still the maximal longest we've seen so far. So the thing is that every left and right may shift one step to the right. This window does not meet the condition, may not meet the condition that right and minus left plus 1 minus max smaller equal to k. But everyone, if they shift left one step, this window meet. Sorry, this should be greater, right? If this is greater, and if they shift one step to the left, we'll have shift left. We'll have the plus minus left plus 1 max smaller equal to k, right? So after this if statement, the window size between left to right is the maximal 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 right minus left plus one. We will see so far the maximal length we see so far. So then we don't need this condition, right? We don't need this condition. We can have the longest here to compare the longest every time. But the thing is that for this window left to right, as long as it expands to a specific length, it will not shrink. So actually, we can calculate the length only once at the end, right? So we'll have a longest equals right minus left. Okay. Notice here minus right and minus left. We need to add one because the right is included. But after we go out of the for loop, the right will be n, right? You can also write a minus left. So doing like this, the time complexity will be O(n), and it's not O26n, right? So in case these characters, for example, this is not just a 26 character, we have more than a large number of characters. We can do it like this way, right? So basically what we are doing is that this is the right pointer. We trying to see whether the mate, the maximum flip smaller equal to k, right? If it's the mate, then we keep the right pointer. If it does not meet, it means left to right have one more steps. Window is one more size than the maximum. Then we move that to the left, move left one to the right, right? And now the left and right, they may not meet the condition that they have a maximum flip less equal to k. But if they both shift one to the left, they have the condition. Yeah, so if both shift right, the left to right, those kind of size, they keep the maximal window we see so far. If they meet condition, right? If we meet condition, then we expand left again, right? And until another scenario does not meet, then we move left pointer one step, right? And in the end, this will go out of the window, right? Go out of the end. And what the left and right, the size between left and right will be the maximal window, maximal size we kept, or the maximal size we made in the string. So doing like this, it will be an O(n) time complexity.